Now that we're done with collections, let's move to the next major topic, which will be control flow. Now this will be a little more complex than what we've covered previously, and so we'll take maybe 3 or 4 different sections to cover in total. The first is going to be focusing on what control flow is, and we'll take a look at the simplest type, which is going to be if statements, and if expressions, which is kind of new to Kotlin, something I haven't seen in a lot of other languages. Then we can move on to when statements and expressions, and then while loops, and finally finish up with for loops. So let's head on over to main activity. As you can see, kind of wiped everything and moved it to collections text so that we can start afresh. So what exactly is control flow and how do we use it? Well, control flow allows us to test for certain conditions, typically return some kind of a true or false result, and then we get to execute pieces of code or choose to not execute that code based on whether the test results come back true or false. So this is very powerful and important for us because we don't want to be executing every single line of code every single time. We want to be able to perhaps move to a different page if something happens, or just execute an entirely different block of code if some condition evaluates to true or false. Consider a real-life scenario where a door might be shut or locked, okay? Well, if the door is locked, we want to unlock it and then open it. But we have to first test to see A, if that door is shut, and B, if the door is locked, okay? So there's going to be different behaviors to execute based on whether the door is locked and whether the door is closed. Each of these, if we were to simulate in a programming environment, would require its own test and then its own code block. Okay, so if statements are the simplest form of this. It's basically just a read for some kind of a test, and then we get to execute some code if that test is true. So it reads something like this: if condition to test, okay, and then we have these blocks here, and then this is just some code to execute, so execute code if true. Okay. So if this condition evaluates to true, we execute this code, and if this condition returns a false, then we simply skip over this code and then continue on with the rest of the execution, any other lines of code below this. So let's actually demonstrate an if statement with that example of the door being open and closed. We'll have maybe some variable that is going to be is door open, which is going to be a Boolean variable. Let's set this to be false, so we'll pretend that the door is closed for now, and we'll have a variable which is going to be an action, which will just be a string for now. Okay, let's just set it equal to a blank string. And so if the door is open, perhaps we want to change the action to come in, and if the door is closed, perhaps we want to change the action to open. Okay, so the way in which this would read is something like if is door open equals true. Remember the double equals for testing purposes. And then we would say action is equal to come in. Okay, and actually let's be a bit more specific. Let's say enter. All right, so this is all well and good, but what happens if the door is not open? If door is open equals false, which is the case here. Well, in this case, this returns false, so we simply skip over this code, but then nothing else happens. We'll probably want to write an else case for this, which is basically a way to execute some code if all of the above cases return false. So we can say else, if the door is not open, then maybe the action would be to open the door. So open door. Okay, maybe a little better. Now this is fine. We're saying, okay, if the door is not open, then we're just going to open the door. If the door is open, then we'll say enter, and then we'll skip over this piece of code here. This only really gets executed again if everything above it fails. However, this still isn't as robust as it should be. There might be a third case that we described earlier, which is is the door locked or is it unlocked? Okay, so we should probably test that before we try to open the door. And we could say, actually, let's create another variable to represent that, is door locked, okay, which is going to be a Boolean type variable. Let's set this to be true to start off with. And we're just going to first say if is door locked, then oh, actually, I should be explicit, so I should say if door locked is equal to true. We set our action equal to just leave. Perhaps we're not even going to try to open it. We don't have the key or anything like that. Okay, well, in this particular scenario, it might actually be a bit more efficient to turn this if into an else if statement, because in this case, this is being tested, and regardless of whether or not this returns true, this is also being tested. So we'll want to change this to an else if, okay, and the way this reads now is if this fails, we'll try this test. If this fails, then we'll execute this code. But if any of the above tests pass, we execute that code and then we exit. Now we can actually go one step further than this and test multiple conditions within one if statement. So right now we're just testing one condition per if statement, but with the, the and the OR operators, we get to specify whether we want to test multiple conditions and have them all return true and then execute the code, or if we want to test just a couple of conditions, and if one of those is true, then we'll execute some code, and so on and so forth. So we'll just stick with the AND operator for now, and I'll let you test out the OR operator on your own time. We're just going to say we're going to create another variable for this purpose. This is going to be does have key. Going to be again a Boolean, and let's set this to be true. Okay, so in this case we're going to say if is door locked equals true and does have key equals false, okay, then we're going to leave. So the way this reads is if this is true and this is true, then execute this code. Whereas if either one of these is false, okay, then we're simply going to skip out of this and we're going to go to the next test. So with the AND operator, both cases have to pass. With the OR operator, only one of them has to pass. If both of them pass, that's fine as well. Okay. Now we can also do stuff like nested if statements. So maybe within this if statement, I want to have another if statement. Okay. Like I said, we've seen that if we take out the else and just have two if statements, then both are getting tested regardless of the outcome of either of them. And so the only other thing I wanted to show you is the if expression. So this is a little similar to the Elvis operator if you've ever used that in other languages, but is essentially just a way to perform a really quick test and then produce some kind of result based on the outcome of that test. So let's say we wanted to skip all of this stuff and we just want to test to see if the door is open or not and dictate what our action should be. We can actually shorten this entire process, skipping all the locked stuff, to something like this. Action equals if the is door open equals true, then it's equal to enter, else just going to be equal to leave. So let's say we can either come in or we're just going to leave. So the way that this reads is if the door is open, then we're going to store the result of enter in action. Otherwise, we're going to store the result of leave in action. Okay, so it's just kind of short form for if is door open equals true, then in the curly braces, action equals enter, else action equals leave. Okay, so I think this is really cool. It does save a little bit of time. I mean, if you've ever used the Elvis operator, it's doing pretty much exactly the same thing, just slightly more readable syntax. But it's important to note that with this kind of notation, you need an else clause. Like you can't just leave it as is, because what happens if this is not true, then what is action equal to? All right. So if you're new to if statements, else, if, and else statements, and especially the expression side of things, then I'd really, really highly recommend you try out some of this stuff on your own. Feel free to use your log statements to print out results to see what the results of certain tests are. And once you're comfortable with all of this, let's move on to the next section, which will be when statements and expressions, which are actually very similar to this kind of a setup.